Hello, beautiful people. It's me. Welcome to another programming workup of mine. I have two timers in here. This is the 5 minutes countdown for the typing, and here's 25 minutes for improving myself in other stuff. So let's start with it, shall we? So let's do this. Oh, yeah, so this will this, that, that, that. Okay. All right, and I have few seconds to go. Right in time. 4%, that's good. So I'm improving with this new layout of mine. And we We'll do the rest of the time. We'll try go through a little bit of the next lesson. I will not complete it for sure. Okay, and the time is up. So that means we are done with this guy. So stop it, reset it, and we will continue in the other thing. And we were doing JavaScript previously today. So I will continue in, that is a draw. Okay, so let's do SQL, shall we? Let's go. Select number 2, 17. 17, like so. Okay, that should be it. Creating cats, text, age, both of them. Then we are inserting a cat, name, age, and then we are selecting things out. So you'll have age, that will be 3, and then we have next year, and that will be 4. Okay. Create table users, ID primary key, name, not now, and discount ID. That is a Ford key. It discounts. And then we are creating discounts, and that we have a ID, that's the primary key, and discount code. That is a text which is not null. Then we are inserting, I will try not to look at the comment, insert into users, Amer and null. So users discount can be null, so this is okay. So we will get this select 2 times 3, so it will be, I think this, like 2 times 3 equals 6. No. Okay. It's not inside of the object. Okay. Never mind. Write the groom function, inserts a row for the given cat name when one doesn't exist. Update the row if given cat name already exists, and uses on conflict do update to do both. So that would be a function groom. And there will be just one SQL statement, and that will be insert with on conflict update. And on conflict do update set, and that would be groom, increase the number in there on conflict, and we will do have a cat name, and I'm missing music. I'll find myself some music. Okay. Okay. So we are doing this. Then we will do update set count equal to count plus 1. That should be it. And it is. We are creating people table, with ID, primary key, and name text. Then we are inserting two guys in there, and we are saying no for the primary key. That is okay. It will insert something in it anyway. It will generate a thing. So the first will be ID, and that is 1001, and the name is Amir. Name Amir, and the second guy will have increased the ID. It takes the last value and increases it. So 1002, 1002, and main will be Amir as well. That's correct. We are creating a table, and we have a creating table people, ID, integer primary key, and the name, this text, which is not null, cannot be null. And then we are inserting two people in there, and we are setting the two same primary keys, 1 and 1. And that is a problem, and I think this will result in error. And it does. Now, the next one, we are creating a users table with ID, integer primary key, and name text, which is not null. Then we have a comment with user ID, which is a foreign key points to user's ID and cannot be null. And the comment text cannot be null as well. I will try to ignore the comment. And look, we are inserting into comments. There's a user ID and comment text, and the user ID is null. And that cannot be because we said it should be not null over here. So this will be an error. Like so. And we create users with name text, and we are inserting, and we are trying inserting into a column which is not there. So that is an error as well. Then dolež mi to vodou, čisto. Next thing we are, where did I? Okay, so we have a table groupings, ID integer primary key, cat name, text unique not null, unique cannot be null, and count is not null. Then we are inserting into Mr. Floss Fun, and then also we are inserting the same thing when we do have a conflict on a cat name. We do update set count +1. So when we select cat name and count from groomings, we will get result, and cat name will be Mrs. Fluff. Fluff, and the count will be 2 because we did the update on the last, well, the last line for the third exec, for the third query. Write a find user function that finds a user by their ID. Finds a user by their ID, return the user object itself, not the full query result array. Okay, and here is some hints. If no user found this, we should return null. Okay, so we will select and we will select that is the ID and name. So we will select everything from users where ID equals, this not equals, this is equals to question mark, and we will provide the parameter, and that will be ID. Like so, close that, and then we will check our result. So if we get empty, we return no, so we'll do that. If query result len is equal, oh, I have to x equal 0, then we will return null. I can write it on one line or whatever. Return null. Otherwise, we will return the we will return what? Okay, so they don't want the array. They want exactly the object. So we will otherwise will return query result, and here we will put 0, query result 0. That should be it. It also could be written in one line, this thing using the ternary operator. This thing, but I will not rewrite it now. It is good enough for this exercise right now, and bam, and we are correct. So next thing, okay, so we have a two tables, people and cats. The people has ID, which is an integer, primary key, and cannot be null. And the first name, it's just text, also cannot be null. Then we have a cats. All of the fields cannot be null. ID is the primary key. Owner ID is integer and name is text. Then we say that the owner ID is a foreign key and it references to the people ID. Then we are inserting Amir and his cat, and then Kinu, Betty and her cat. And then we are also inserting second cat for Betty. Okay, now here is our select query, and we are selecting people first name as a person and the cat's name as a cat from people, which are joining cats on people ID equals cats owner ID, and where is the Betty, so all cats from the Betty. So we will get two results. One will be the person and Betty, that is a given, and then we have a cat, and the first cat is called Kinu. Here we go. I have a typo in there. I mean, not a typo. I have a mistake. This should be in quotes. And the second will be person. It will be Betty as well. And cat will be what is it? Kim, like so. We'll close this object and close the result array. Boom, we are right. Use a join to find cats and their toys. The join should return two columns, a list with as cat, the cat's name, and the toy's name. Okay, so we will select uh, uh, cats.id as cat. Then we will have uh, maybe I will remark my keyboard again. We'll see. So the second one will be toys dot name as what is a toy? Okay, uh, from from cats join toys on cats.id equals toys dot what is it? Cat ID and everything else we want. We have the cat and toy things. We are joining them. We're pairing them correctly. That looks like we are done here. Cat one. Oh my god, I said cat's ID instead of cats dot name. Oh well. Lesson learned. Select, oh, this one. Okay, so I did this mistake, so perhaps this will be correct. We'll see. So T2 times 3, and it will be 6, like so, and close that. And that is correct. Okay, good. And the second problem we had is so we will select cats dot name as cat. Then we will have toys dot name as toy. Then we will say from cats join toys on and we will say that is cats dot id equals toys dot and that is a cat id this is the correct solution. Okay, good. Left and right joins, let's go. An earlier lesson, we saw an example where users can register with discount codes. The discount codes were optional. Some users register with code, so they have a foreign key to the discount. Other users register without a code, so the foreign key is null. Suppose that we want to peruse a report listing or users and what discount codes they used. The report should include all users, whether they used a discount code or not. Report should, okay. We could write a loop in JavaScript. Loop over each user, selecting any discounts for that user. That would cause an n+1 query problem. We'd query all of the users, followed by individual queries to get each user's discount, if any. We can do that with join, right? Normal join. Why do we want left and right joins? As usual, SQL has answer in this case. It's a join. However, the type of join that we've seen so far doesn't help us. If we select from users join discounts on users ID equals that, we only get results for users who have corresponding discounts. Okay, so what we want to produce a report listing all users and what discount codes they used. Include all users, okay, whether they use discount code or not. Okay, I see. We only get the results for users who have corresponding discounts. The user's ID equals discounts user ID will never be true for a user who has no corresponding discount row. Got it. That doesn't solve our problem because we want to include all users even if they have no discount. Here's an example of that solution, even though it doesn't solve our problem. So there is a creation of the tables, then we are putting in, and then the interesting part is happening here. And that is from, yeah, that's the solution. So we will get just a mirror, not Betty. Well, the row with a mirror, not Betty. Okay, so we will get a name, and that will say a mirror, and then we will have a discount code, and that will be the discount code is a free month, and we can close that. Betty existed, but she wasn't in our query's result. To fix that, we can tell the database to include users in the report even when there's no matching discount. This is called a left join. Okay, so users left join, that means all users. The left means include rows from the left table users, even if there's no corresponding row from the right table discounts, okay? With a left join, both Amir and Betty will show up in the results. Amir will have his discount code, but Betty's discount code will be null, which will be represented as JavaScript null. Okay, so now we have the same thing, but the join is different, I suppose. And so we will have a name. The first one is Amir, and the discount code is free month. H, like so. Then I will close it, and then we will have a Betty. So the name will be Betty, and the discount code will be null. I'll close the results, and we are correct. Left join adds one small tweak to our mental model of joins. Inner joins, the simple kind that we've seen without left, still work in the same way, but there's how the database executes a left join. The new part is the if no discounts magic to this users section. For each user, for this discount, if user discount ID matches discount ID, return row with all, okay. If no, match return row with all of the user column, and null in all of the missing columns. Okay, as usual, this is only mental model, but it's a correct one. In reality, the database will use more efficient method that gives exactly the same result. You might wonder whether left join implies that we are also a right join. There is. In a right join, rows from the right table are always included, even if there's no corresponding row from the left table. Left and right joins are much less common than the basic inner joins that we've seen before, where every row must exactly match the on, but when you need a left or right join, you'll be glad that it's available. They are useful when you want a list of records like users along with other corresponding records like discounts that might not exist. As it's often, okay, we run out of the times, I don't know. As it's often the case, SQLite is a bit weird here. It supports left joins, but not the right joins. Fortunately, we can convert right joins into left joins by flipping the order of the tables. Like with basic inner joins, left and right joins will produce any combination of rows that match. For example, suppose that we select from users left join comments on users ID comments user ID users left join comments. Okay, so here users had a multiple comments. Alright, so that will be reflected. Every comment in the database will show up in the results. If Amir has written 100 comments, he'll show up 100 times, once with each of his comments. But because it's a left join, every user is guaranteed to show up at least once. Betty will show up even if she's never written a comment. Here's a problem for me to solve. Use a join to get a list of usernames and comment text for every comment in the system. Make it a left join so that it also includes users who have never written a comment. They will have a null comment text. Select only the name and comment text columns. Okay, so we will select comment text and the name. So we do that. So it will be, what is the table? Comments, comment text, comments dot comment text as how can I do just this? Maybe I'll try. Then we want to select that was a people.name right now, users.name, users.name, and he will say from. Then we want all. What do we want? Okay, we want. There's Amir as well. So we want each of the comments. So we will from comments left join users on, and here will be comments dot user ID, and that should be equal to users.id. Okay, so we have a common text, that is good. Then we have Amir, then we have a common text. This is for dislikes mother, name, Amir. Oh, we want all of the users. Okay, so it should be the users left joint comments. So we'll fix that. Users left joint comments. That's correct. You'll sometimes see left and right joints called left outer joints and right outer joints. Fortunately, outer doesn't change the meaning. It's just a more precise name for the same idea. Okay. So left outer join and left outer join and left join is the same, and right outer join and right join is the same thing. In this course, we only address inner simple joints and left joints. However, there is a surprising array of additional join types. For 99% of your practical work, inner joints will be sufficient. Left joints will probably get you through the final 1%. We don't recommend focusing on other join types until you spend a lot of time using SQL databases on project. However, if you'd like a taste of how deep the join rabbit hole goes, we think that this article is thorough and understandable without belaboring the point. Okay. And we are 6 minutes over at the end of the lesson, so that means we are done. Done is better than perfect, and I will see you next time. Bye.